Now, okay, I'll tell you mitochondria story.
Okay.
Okay. Once upon a time, long, long ago, means not 2, 3 years, maybe hundreds of thousands of years ago, maybe even millions of years ago, there were no life on our planet. Everything was non-living. And then, at that time, there was no oxygen in our air. You know, we breathe oxygen, right? That is how we get strength, muscle, right? We grow. We need oxygen. And about one fifth of the air we breathe is oxygen. And at that time, there was no oxygen at all. And how could people live there? It is not possible. At that time, we had air in our atmosphere. That air had water vapor was there. There are some molecules where atoms are combined together called methane, and there were carbon dioxide which we breathe out, but they were already there. And it is much before humans could ever breathe out because there were no humans at the time. That means these things were all in the atmosphere, and there were clouds, and there were lightnings and thunder. Nobody to hear the thunder, nobody to appreciate the beauty of the lightning. Still, there were lightning and thunder, and in lightning, things get very, very hot. You know that, right? Now, when at that high temperature, the carbon dioxide, water vapor, and this methane, they all reacted together, and there were some tiny, tiny molecules formed, atoms combining together, and they dissolved in the water, and they combined in process of time gradually to make the first molecules needed for life. And in long time they combined this way, that way, all possible and almost impossible ways. Some of them started showing the characters of life. That is how life started. Now those lives were simple lives. Those cells of them, or the small box in which it is contained, didn't have any nucleus. See, if we take a cell from our hand or our blood and you look in the microscope, you can see a small nucleus round thing, approximately round thing, in the middle of the cell. But those living things didn't have any nucleus, okay? And still they had life. They could take food not through the mouth, they could absorb from the environment, and they could grow, and they could divide into two to become, so that community will increase in number. And they never married, they were never given in marriage, there were no rituals, still they reproduce. They became more than one, then four, 5, 10, 100. They and they started changing. You know, when you are a little baby, you have a little bit of round head and you have a little bit of curly hair, and then they will all fall away. So you change. Living things change. Change is one of the characteristics of living things. They did change. And when things change, lot of different forms, ways in which they can change. So some of those bacteria started using the carbon dioxide in the air and trying to make food from that. And in the process, some waste was came out. You know what the name of that waste is? That is what we call oxygen. Okay, so oxygen was a waste product, and if we don't eat waste, that can be dangerous, right? That can kill you. So this oxygen could kill people, could kill living things. Lot of Because oxygen has a lot of potential capability to get reduced to water. In the process, lots of energy is coming out, like a small, tiny, puny little atom bomb. Okay, it is releasing energy, and that energy can cause fire, and it also can cause changes in the tiny little things, internal systems. Some of the molecules can be changed. Some of the small parts of the membrane of this tiny living thing could change. So it could kill. Now, how can you survive that? Some of those things made their own machinery, their own systems to get rid of that, okay? Or to overcome the destroying capability of oxygen. But then, you know what happened? Some funny living thing thought we can use this guy to make energy, okay? So they started using energy. And that is how we started breathing. So now the bacteria breathe, plants breathe, cows and dogs and cats breathe, we even humans breathe. We all use oxygen. And oxygen started increasing more and more and more. Now, if you have 100 gallons of air, approximately 20 gallons will be of oxygen. Why the light? Oh, that is what.
It's still there. Yeah.
Okay, okay. And that is how the oxygen came. Okay. Now, once oxygen is there, the small, tiny living things said, "Let us grow more. Let us grow bigger. Let us like an ant becoming an elephant." Okay. They wanted to become an elephant. Then, once it is a big elephant, there's problem because elephant has a lot more cells in that, the big cell. Okay, a lot more components, and everywhere the nutrition has to go. And you know what they used to eat at that time? Carbohydrates. For example, our glucose or table sugar, which is glucose combined with another glucose-like molecule called fructose. That is table sugar. And they could eat the glucose and make energy. And you know what is energy? Currency. Like if you are very rich, you have a lot of money. Money is not the richness. Money is what you carry with you so that you can use your riches to buy something else, like a car or a ship or a beautician to make your hair look more pretty. Okay? So, the currency of energy in a living system is called ATP, adenosine triphosphate. You don't have to remember that, okay? I'm just telling you, just to scare you, just to let you know that I know that. So, it's little of show off, okay? But that is called ATP, adenosine triphosphate. Now, one day they were living in their house of a cell with a nucleus, and somebody knocked at the door. And it was winter time, very cold, and when they opened the door, there was a puny little guy, the old bacteria, standing outside. So the lady of the house asked, "What do you want?" He said, "May I please come in?" "I don't even know you. How can you come into my house?" He said, "I am a poor bacteria living on the street. I don't have any food. I don't have a house, and it is too cold outside. Can I just warm myself up in your house?" Then the lady of the house looked at him with a little bit of contempt. "Okay, okay, you can stay maybe for 1 hour. Then you have to leave." "Okay, that is enough. Go to it." In the meantime, there's a lady of the house was cooking food in the house, and she was taking a glucose molecule, and she took she cooked it, and 2 ATPs came out. The rest of the stuff she threw out, and this guest was looking at it. Then guest asked, "May I ask you, ma'am, why are you throwing that thing out?" Then the lady said, "It is useless. It is waste. We cannot use it. So I am going to throw it out." Then the visitor asked, "Okay, ma'am, can I show something to you?" "You showing something to me? This is my house. You are a puny little bacteria coming from outside. Do you think you are bigger than me?" "Maybe you are right, ma'am, but I just want to show you something." And then the lady said, "Okay, you do whatever you like." So he took one of the stuff they are throwing out, that's called pyruvate, and they took the pyruvate, and she did something like that, immediately came out. You know how many ATPs? 16, 17 ATPs. And the lady was impressed. Okay? And she thought maybe it is a fluke. She gave another molecule of pyruvate. She made another 12 or 13 ATPs. "This is not bad." The lady said, "Now you don't go out into the street anymore. Just to stay with me in my house. You are our favored guest. You are our honored guest. You will get all the protection, all the shelter, everything you need. Okay, so from that time, that bacteria is called mitochondria. Okay, mitochondria lives in the house of the eukaryotic cell with a nucleus. It makes ATP, whereas the eukaryotic cell can make only two. This can make a total about 32 ATPs per one glucose molecule. Okay, it is still we are descendants descendants of that eukaryotic cell. We still have every cell of us has mitochondria, but there are some cells without mitochondria. Do you know what? Our red blood cells, they don't have any mitochondria. They don't have any nucleus either, but they don't live more than 3-4 months. Then they die. Okay, but they have get all the other energy from whatever they whatever they can make. That's enough for them, and we are living happily ever after. Bye.